Hello students, welcome back. So now we are going to be focusing on univariate analysis on categorical columns. The word univariate means single variable. In other words, we'll be focusing on only one column at a time. So first thing I'm doing, I'm importing my pandas as PD and I'm also importing my matplotlib. So this will help me visualize my data. So let's load our data. So in this case, I'm reading my pickle file. So this is the same data. This is the data mpg clean.pickle. So this was a pickle file that was saved in the previous step. So if you do not have this pickle file, you can actually read the CSV file too. That's present inside the same directory. One of the advantage of pickle file, if you recall, was that it saves the data type. So in the previous step, I actually had changed the data type to like lower data type. For example, I changed to int 16, I changed to a category, I changed all those things. So now I'm reading my pickle file in this instance. So then I print the first 10 samples. So these are my first 10 samples right here. Okay, and then come down. And let's say I want to see my memory usage of my data frame now. So when I print my df.memory, and you can see that now, since I'm reading the pickle file, it's going to show me float 16, uint 18, uint 16, because this was how it was changed before I saved it into pickle file, if you recall. Uint 8, uint int 16. So these are the data types now. And also you can see the memory usage is way low than the original file. But if you're using the CSV file right here, this one right here, if you read this CSV file, your data type would be different now. Okay, and now I'm going to print my categorical column. So one way you can print a categorical column is by using this little syntax, df.select include category columns to list, and that's going to print out all your categorical columns. In this case, it's only going to print one column, origin. That's because over here, in this my data type right here, it actually is, there's only one origin over here. Origin is the only one that's category. But if you're not satisfied with that, maybe you want to have manual, you can do manual too. So just come over here and just comment this line out and uncomment this part out, and you can now select your own categorical column. So maybe you believe that origin, model year, and cylinder, this should have been categorical, and maybe that's what you want to investigate. So in this case, you can manually select that. That's what I'm doing in this particular instance. So now I want to answer this question: which categories appear most or least? So let's say my category columns are origin, model year, and cylinder. This is the one that I manually entered. So I'm iterating through each one of the category column and I'm printing the value count. So when I run this, it prints out the value count for each one of them. For USA, there are total 249 records. For Japan, 79 records. And for Europe, there's a 70 records. Likewise, for the model year, you can see that the cars that are made in 73, there are total 40 records. For car that was made in 78, 36 records, and same thing with the rest of them. And then you have cylinders right here. For four cylinder, there are 204 records. So you can see just by looking at this, you have more cars from Japan and least car from Europe in your data. In your data, you have pretty much equal distribution. You have 40, 36, okay. Cylinder, it seems like you have a lot of data for four cylinder right here. There are 204 records for four cylinder. Uh, let's see the percentage stat on the categorical column. Maybe you want to see the percentage. These numbers may not give you the relative strength of these count. So in this case, I'm actually using the same thing above, but in this case, I'm specifying normalized equal to true, and I'm multiplying by 100. So when I run this, it gives me the percentage for each one of these columns. For your origin column, your USA, 62.56% of your data contains USA. 10% of your data contains 73 model year. And you can see the 9, 8, 8, 7, 6. Okay, 6% is like 74 year. For cylinder, 51% of your data contains four cylinder cars. And now let's do the count plot for the categorical columns. So by the way, this particular step is optional. And what I'm doing, I'm just choosing my background. I'm saying my background, I want dark. And I want the all those bars and everything to be gold. I want my font size to be 14. I want the X-tick label size. I'm specifying all these things. So this is an optional. Don't have to do this particular step. You can skip if you want to. Okay, so let's do a simple plot for only one column. Let's say it's origin. So in this case, you can use data frame and you can call this inbuilt method plot. And you call the kind equal to bar, and when you run this kind plot plt.show, that's gonna print out this particular bar plot for you. You can see that you have USA, Japan, and Europe. So let me decrease the size of the screen so you can see that now. And there you go. You can see that USA has more cars, Japan has less cars, and then Europe also has less cars. So it seems like Japan and Europe, they have pretty much the same number of cars, but your USA is dominating. But over here, you are not able to see actually the numbers. Maybe I want to see the actual numbers. So in this case, what I'm doing, I'm actually using the same data, but now in this case, I'm just saying value count dot reset index. Then I'm printing the value count for each one of them. I'm also printing out the percentage. So when I run this cell right here, that's going to calculate the raw data and also the raw percentage. And then I print out my data right here. When I run this, it tells me for USA, the actual count is 249 and the percentage is 62.5%. For Japan, there are total 79 cars and 19.8% of your data has Japan. And same thing and likewise for your Europe. Now you can do this thing for all columns individually, or you can use a for loop. So in this case, I'm just choosing to use for loop. So this is my cat columns right here. I'm going to iterate through every single column. I'm going to plot each one of them right here. And after I'm done plotting, I'm also printing out the data in the same graph right here. So in this particular instance, it's gonna basically this code is same as the one on the top. There's no difference over here. I just did copy and paste over here. That's all I did. So when I ran this thing, it's gonna print out each one of the counts in this particular instance. So let's come over here and let's run this and come down, and now you can see that. So this is for the let's say origin, and now you can see the raw counts for the origin. So US is 249 percentage is this, and then this one is for your cylinders. So you have 4 cylinder, 8 cylinder, 6, 3, 5 cylinder. And what is the count for 4 cylinder? Well, the count is 204 records. 51% of your data is 4 cylinder, and 3% of your data is 5 cylinder. That would be this right here. Okay, what about this one? This one actually is model year. So you have 73. This is the top one. So 73 and 74, that is this one right here. So let's look at the raw numbers. So for 73, for model 73, your total number of records is 40. That is 10% of your data is year 73. And then the least would be this right here. So for year 74, that's the least one, and 6.7% of your data is the year 74. So on a side note, sometimes you come across data that has a high cardinality. So for example, your model year. So in the case of model year, maybe you want to print only the first six and you don't want to print in a vertical manner. Maybe you want a bar that should be horizontal. So you can do that too. In this case, you just specify kind equal to bar edge. So in this case, I'm saying just print out the first six of them for the year model year. When I run this thing, you can see that it prints out 70, year 70, year 75, year 82. It only prints out the data for those ones. And year 73 has the high cardinality. So it's going to print out the first six: 1, 2, 3, 4, 5, and 6. So this way you can see that visually over here.